Happy day to my dear students. And today we are going to discuss about the cardiac output indicator dilution method. So whatever the title we are reading, okay, the answer will be in the title itself. So that is indicator in the sense we are adding some indicator, okay, and that indicator will respond to our process, and at the end of the process indicator value will be changing. So this is the uh, indicator method. Okay. So again, the indicator method is classified into two methods. One is continuous infusion and another one is bolus injection method. Continuous infusion is not widely used. The reason is indicators are recirculated. Okay. Indicators are recirculated, okay, in order to get the precise value, in order to get the accurate value. So again, it is very difficult because the concentration of the indicator will go on increasing in that continuous infusion, because we are continuously adding is nothing but infusion. We are continuously adding the indicator in the blood, okay. So that is why that method is not widely used. Next one, we can see the bolus injection method, okay. So here the indicator is added into the heart, okay, through the vein. Okay. As I said earlier, the vein looks can be viewed clearly, and it is big in size compared to the arteries. Okay. So what is happening here is the presence of indicator is measured and recorded. The presence of indicator is measured and recorded. So again, this is also the same. The concentration of indicator entered and left will be the same procedures. Cardiac output. So from that chart readings, we can identify the amount through the cardiac with comparing to the chart. Okay. Next, indicator dilution method. In this method, the amount of cardiac output is calculated using this formula: Q equal to M divided by average concentration of indicator per liter of blood for duration of curve into duration in seconds. Okay. So that formula is simplified as Q equal to M divided by integral of C, that is concentration, from 0 to the time what we defined, T dt. So here you can see the area, okay. So this is the concentration, it is the area under the curve, concentration of the indicator, area under the curve. So this area must be added must be indulged in this C0 to T. Okay, concentration of the indicator area. So by this method, this is the normal one for the indicator dilution method. So first we are going to discuss about dye dilution method. Dye dilution method. In this dye dilution method, dye is injected into the veins. Okay, and that vein is allowed, that blood is allowed through a absorbing channel. Okay, it can be a tube or it can be some form of glass, whatever it can be. Okay. So first the dye is inserted into our blood. Okay, which type of dye? Yeah, that is isocyanate. Okay, green, black. It will be looking very dark green color. Okay, very dark green. The property of this dye is it absorbs light. It absorbs light. Okay, so it absorbs light, infrared rays especially. Uh, but absorbs light of the wavelength up to 800 nanometer, and an infrared photocell transducer is utilized. So this one is the lamp and this is the photocell, and that photocell will detect the amount of light incident on this. Reason is, initially, when the dye is concentrated, that is when the dye is heavily concentration, therefore the light received on the photocell is minimum. Okay. Later, in the second cycle, it will get diluted, and again the light from the lamp received to this photocell is somehow better compared to the previous cycle. Okay, so here the photocell output is measured and recorded for the amount of blood left from the heart. Okay. So indicated dilution method. So this is our heart. Okay, that is the output, and we are adding an dye, and here the time is there, and finally we are measuring. This is a simple setup that is given for the demo, for the understanding purpose. Okay. So next one is thermal dilution. Okay, thermal dilution. So thermal dilution is the temperature of the heart is taken into account. Sorry, blood. Temperature of the blood is taken into account. Okay, so here the temperature, the thermistor of the blood, the thermistor of the temperature of the blood is measured using the thermistor, that is before entering the heart, and again one more thermistor is placed at the point where the blood leaves the heart. Okay, so the difference in temperature entering and leaving will give the amount of blood that is left from the heart, the cardiac output. So this is a similar one, and here we can find that the thermistor is placed at the tip of the heart. So next one is cardiac impedance change. Cardiac impedance change is determined electronically by using the impedance band. Okay, and in ultrasonic, we will blood flow. Okay, usually the blood flow techniques is employed. Usually the blood flow techniques is employed through the Doppler effect, okay, in ultrasonic, and in bioreactants, this is a non-invasive. Okay, this is a non-invasive method based on the hemodynamic monitoring. Hemodynamic monitoring is hemoglobin. Hemoglobin dynamic characteristics of hemoglobin is monitored, and that method is called as bioreactants method. Okay, hope you understood the topic discussed today, and remaining topics we will see in the next class. Thank you.